Okay, now we've done mole ratios, we can link that in with the mass formula to actually do the full mass stoichiometry. So now we can deal with questions like this, where we're given the mass of the chemical that's involved in the equation, in this case is produced. We can use that to calculate the mass of nitrogen that is required to react to produce that. So it's just linking in the mass formula to that idea of want over got. Now whenever this is a very simple example. They do get a little bit more complicated than that, I'm afraid to say, but which is why I think it's always wise just to start off with the basics. What is this problem asking us to find? Now in this question, it's the first 4 words. What is the mass of nitrogen? But it won't always be as obvious. Once you know what the point of the question is, then next thing is to get that equation. Now, almost always that equation will be given to you. We won't expect you to write an equation in the middle of a stoichiometry problem. So we've got the equation, and that of course gives us the mole ratios. Those coefficients give us the vital mole ratios. Once we've got that, it's the 3 basic stoichiometry steps. Same in every stoichiometry problem. First step is to calculate the moles from the given information. So looking at that question, what are we being told that we can use to work out the moles? Well, we've got the mass of ammonia. So we just have to use the mass formula to work out the number of moles of ammonia. We've got to be able to work out moles somehow. So you look at the question, and what does the question tell us that allows us to work out the moles? Well, clearly in this case it's the mass of ammonia. So simple use of the mass formula. N equals M over MR. And we get our number of moles. Now once we've got our moles, then it's the magic want over got step. Second step is always want over got. So what's the question asking us for? What do we want? We want the moles of nitrogen, or the mass of nitrogen I should say. What have we got? We've just worked out the moles of ammonia. So want over got, coefficient of nitrogen over the coefficient of ammonia, 1 over 2 in the equation. So the moles we just calculated, 29.4, we're going to multiply it by 1 over 2. And that will give us the number of moles of nitrogen required. That's the second step, want over got. Once we've got the moles of nitrogen, it's a simple matter to use the mass formula again to work out the mass of nitrogen that is going to react. So remember, nitrogen is N2. We've got to go 2 times 14 to get the molar mass. And when we do so, we can see 412 grams of nitrogen will be required. Second example goes back to the combustion of propane reaction. Now again, first you look at the question, what are we being asked to find? Again, it's as simple as the last one, the first 4 words, mass of water. The equation, we've already balanced that, that's given to us. Now, step number 1, calculate the moles from the given information. Now, what's our given information? 70 grams of propane. Okay, we can use that to work out the moles of propane using the mass formula. So the The molar mass of propane, 3 carbons, 8 hydrogens, gives us 44. N equals M over MR. 70 divided by 44 gives us the number of moles of propane that burns. Now, next step is step number 2 is want over got. Now, what do we want? We want water. What have we got? We've got propane. Water over propane, 4 over 1. So we're going to multiply our moles of propane by 4 over 1. Tells us how many moles of water is produced. And of course, once we've got the moles of water produced, it's a simple matter to use the mass formula to calculate the mass of water produced. So M equals N times MR. Molar mass of water, 16 plus 1 gives us 18. And it gives us that mass of water. Okay. That's a couple of examples. Have a go at the questions.